This is our last lesson in our prerequisite chapter, and it's probably, again, what I would consider to be the most important reason that we do mathematics is to model real-world situations, so to be able to solve meaningful problems. So what we'd like to share with you today is a 5-step strategy for solving problems, and really many textbook manufacturers and many math teachers have their own set of steps. These are what our publisher uses. So step 1, they say that we should read the problem, which kind of makes sense. Decide what you know, so what is given in the problem and what you need to know. What is it that you have to find? You should pick a variable that represents the unknown quantity. Truly, folks, if we're doing this well, we should have read the problem probably 3 times to do what it asks for here. First time through to get a feel for it, the second time to pick out what you know and what you need to know. And then a third time just to be sure, I suppose. It never hurts to be careful. The second step after that preparation is to actually do the mathematics. Write some expressions for quantities in the problem in terms of the variable that you solved or that you selected. The third step is to write an equation that puts those expressions together in a meaningful relationship. The fourth step is to solve the equation and answer the question. So we solve the equation that we wrote. We are answering a question that was written in a word problem, so our answer should be written in a sentence. Right? Sentences are good when you're solving word problems. And the last step, you should check your solution. Folks, that's the unfortunate thing about algebra, or maybe the fortunate thing. You never should get a problem wrong, because we should be able to check our answer every single time. As we look at a set of problems here, we'll ask you to remember these things. Read carefully, pick a variable, make sure you know what it's standing for, make sure that you can write expressions for other quantities that use that variable, write and solve an equation, and then check your answer. Here we go. According to the U.S. Department of Education, there's a gap between teaching salaries for men and women at private colleges and universities. Go figure. The average salary for men exceeds the average salary for women by $14,407. Combined, their average salaries are $130,015. Determine the average teaching salaries at private colleges for women and for men. All right, I think I have a pretty good idea of what's going on here. The question tells us that we are going to find teaching salaries for men and women, so it might be a good idea to let M equal men's salaries and W equal women's. Then to think about what they told us concerning those salaries. The average salary for a man exceeds the average salary for a woman by $14,407. That means if we were to take the men's salary and subtract the women's from it, the difference between them would be $14,407. So there's an equation that comes from the given information in this problem. But we're also told that if we add or combine their average salaries, we get a total of $130,015. So the men's salaries plus the women's are equal to that $130,015. All right, now we're cooking. Let's see. We want to find the average teaching salaries, so our answer are going to be men's salaries, women's salaries, and we have 2 pieces of information to work with really here. I am hoping that you're remembering we have 2 equations and 2 variables, and if we want to solve for the variables, we have to find a way to get rid of one of them or eliminate one, and I hope that's ringing some bells in your memory. If we were to add these 2 equations together, you would notice we'd get twice m, 2m. But look at this, a minus w and a plus w is nothing. They add up to 0. So we eliminate that variable by adding the 2 equations together. I'm going to show that this way. We're adding those two equations together. On this side, when we add, well, you're going to watch me add. 7 and 5 is 12. We carry the 1. 4 and 0. 4 and 0. 1 and 3. And 1. All right, so 2 m's are the same thing as 144,422. We want to know about 1 m because that will be the men's salary. And if we divide by 2, we'll find, let's see, 2 into 14 7 times, into 4 twice, into 4 twice, into 2, oh, there we go. The average men's salary is around $72,211. That gives us enough information, folks, to find the women's salary because, well, we could do it in one of two ways. I know that men minus women is supposed to be 100 or 14,407, or if I add them together I should get 130,015. I think I'm going to use that equation, and what I'm going to do is put what I know is true for the men's salary in there. So 72,211 added to the women's salary has to give us $130,015. Well, if we want to find the women's salary, we need to subtract. And what we're subtracting is 72,211. So the women's salary, let's see, should be 5 minus 1, 4. 1 minus 1, 0. Borrow. 10 minus 2 is 8. 9 minus 2, 7. We've borrowed from here. 12 minus 7, 5. According to this, the average woman's salary should be $57,804. I want to just do a quick check and make sure that that's true. If we do 72,211 men minus women, which were 57,804, we should end up with that 14,000. It looks like it's going to be close. 11 minus 4 would be 7. 10 minus 0, yep, that's a 0. And let's see, 12 minus 8 is 4, 11 minus 7, 4, and 6 minus, yep, I think we got it. There's our check. So the average salaries are $72,211 for men and $57,804 per year for women. Very good. I think we looked at all 5 steps. We read, we wrote expressions and equations. We solved those equations and answered questions. We checked our answer to make sure it was correct. I think we're doing well, folks. Let's go on to our next problem. Oh, it's totally different. After a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the sale? Okay, so what we're looking for is the price before the sale, or the regular price. I'm going to use an R for that and let R equal the regular price. And then I'm going to ask you to think for just a minute with me about what's actually going on here. The price that you paid after a reduction, it says, was $840, and that was a 30% price reduction. There are a couple of ways that you can think about this problem, but I'm going to ask you to think about it this way. The regular price would have been 100%, correct? You're taking 30% off of that. That means that really what you paid, your $840, that was 70% of the regular price. And the word of in there means that we're going to be multiplying in mathematics. So if you think about this, really what we've done is translate that first sentence into an equation. 840 is, or equals, the regular price times 70%. Now in terms of doing the math here, Of course, we're going to think 840 is equal to, well, percentages. So we move the decimal point 2 places, 0.7 times R for reg. To find a value for our regular price then, we have to divide 840 by 0.7. Here's my famous margin math. 840 divide by 0.7, move the decimal point, move the decimal point. All right, now we're dividing. 7 into 8 goes once, with one left over. 7 into 14 goes twice, and it goes in there equally. So there we have it. The regular price was $1,200. Now, I suppose I should have checked that before I wrote that answer. So I'm going to real quick do this. If the regular price really was $1,200, if we multiply that by 70 or 0.7, we should get here. Okay, so I want to just think about that. 1,200 times 0.7, and I'm going to offset my zeros because that's the way I do this thing. 7 times 2 is 14, and that's an 8. 1 decimal place in the problem, 1 in the answer. Sure enough, checks out. Nice. Nothing like a good percentage problem. Our next example should be near and dear to our hearts. It's a geometry question. It says a rectangular garden measures 16 by 12, and I'll tell you what, before I finish reading, I'm going to start by drawing a picture. That is probably one of the best problem-solving tools. 12 by 16. All right, a path of uniform width is to be added so as to surround the entire garden. So we're going to build a pathway all the way around here. Uniform width. So that's all the same, even if my drawing doesn't look like it. And the landscape artist doing the work wants the garden and path to cover an area of 320 square feet. How wide should the path be? Oh, well, our variable is the width of the path. I'm going to make that x. And we know that it is x on all sides because it said it was a uniform width. Okay, so we're going to add a pathway that's x feet wide all the way around. And then it says that the area of the garden and the path is to be 320 square feet. Do you remember the formula for the area of a rectangle? Length times width. So that total area has to be equal to the length of this garden and the path times its width. And I think that we can write expressions for length and width based on the measurements that we have. We know the total area to be 320. So here's that. The length of this garden, well, it was 16 feet long before, but we've added x on both ends of that. So the length of this garden is now 16 plus 2x. The width of this garden was 12 feet. We've added x onto both ends of that, so now we're talking 12 plus 2x. And, well, it looks like we're going to do a little bit of multiplication here. Let's see, and we're going to simplify. So 320 will equal box method, FOIL, whichever you desire. I'm going to box method. (16 plus 2x) and 12 plus 2x. 16 times 12, I don't know. So and a 6 and a 1. That that's 192. So, all right, 192. 12 times 2x is 24x. 16 times 2x is 32x. And 2x times 2x, well, that's 4x squared. Oh my. Quadratic, quadratic. So let's see. We're talking 4x squared are like terms. 24 plus 32, 56x. And our constant 192. All right, see, we're going to subtract that 320 from 192 and get it set up so that it's quadratic. 0 equals 4x squared plus 56x, and 320 minus 192. 8, 11 minus 2, 128. All right, I'm looking at this, and yeah, I think we can help ourselves if we divide everywhere by 4. That'll make it look a lot nicer, and each of these values is divisible by 4. So 0 divided by 4 is 0. 4x squared divided by 4 is just x squared. 56x divided by 4, well, that's 14x. And 128 divided by 4 is 32. So we're talking about solving a quadratic, and man, it would be sweet if it factored. 32. Well, let's see. I'm going to make my box over here. Actually, really what I need is the x part of it, since the coefficient here is now 1. I have to have things that multiply to make negative 32, but add to make 14. So 32, well, that's 16 times 2. So if we went 16 and negative 2, does that work out right? Sure, signs come out right. Adds up to 14, multiply. I think we're good. So remember, since the coefficient was just 1, we can say now that our factors are x plus 16 and x minus 2. Now, we're not quite done. We factored, but we don't have a width for this path yet. So we need to solve these equations. Remember, one or both of them could be equal to 0. So, boy, I'm going to take up a lot of room to solve this problem. Our two values for x, the possibilities are, if x plus 16 is 0, then x is negative 16. If x minus 2 is 0, then x is 2. Ladies and gentlemen, one of those things is a good answer for this problem. I don't think we can have a path that's negative 16 feet wide. I believe we can have a path that is 2 feet wide. So our answer, see, we've got an extraneous root, it's called, one that is correct mathematically but doesn't make sense in the problem. So that negative 16 is just out, and the width of the path should be 2 feet. All right, good job. I'm going to move on to the next page, and let's see what we have for you. Oh, life wouldn't be life without geometry. The Pythagorean theorem is going to be a great problem-solving tool for you. We'll use it a tremendous amount this year. It's probably the most important mathematical concept we hit in high school, and so we're going to use it here. It says that we have a radio tower supported by 2 wires that are each 130 yards long and attached to the ground. That should be ground. 50 yards, so I'll just put a G there and we'll pretend that I didn't see that typo. Attached to the ground 50 yards from the base of the tower. How tall is the tower? A picture is in order. So we have a radio tower, and I am not the world's best drawer, but there it is. It's supported, it says, by 2 wires. So there's one, and there's one. that are each 130 yards long, so that's 130 yards, as is that, and attached to the ground 50 yards from the base. So a 50 belongs here, and a 50 belongs here. Good. Our tower's in the middle. The question is, how tall is the tower? There, folks, is our variable. The height of the tower is going to be our variable x, and the Pythagorean theorem applies here because we make the big assumption that the radio tower makes a 90-degree angle with the ground. Okay? That assumption is okay. You'll remember the Pythagorean theorem. Pythagoras was a very smart Greek guy, and he said a long time ago that if you square the hypotenuse in a right triangle, it will equal the sum of the two legs squared and added. Now, I know that many of you will be thinking, I thought that was a squared plus b squared equals c squared, and you're right, that's the way we learn it often. However, as far as sense making goes, we square the two leg lengths. The hypotenuse is 130 yards. We square that. That has to be equal to the squares of the legs, 50 squared plus, I don't know yet, squared, added together. So we've substituted into the formula. 130 squared, that might be daunting to some of us, but probably not. 13 times 13, well, maybe, we'll see. We bring down that 0. 3 times 0 is 0. 3 times 3 is 9. 3 times 1 is 3. 1 times 0, 0, 3, 1, 0, 0, 9, 6, 1. Oh, all right, 169, 16,900 is equal to, well, 50 times 50, we can do that in our heads, folks. That's 5 times 5, 25, with 2 zeros on the end of it, plus x squared. We're going to subtract our 2,500 from 16,900. Um, 0, 0, 4, 4, 1. 14,400 is the same thing as x squared, and to find x we take the square root, and I just have a sneaking suspicion that you know this one. I believe we've got a 12 with a 0 after it. Now you can check me on the calculator, but I believe that you will find this to be true. If we did 120 times 120, that'd be 12 times 12, 144 with 2 zeros. I believe that our guy wire, or our tower, sorry, the tower is 120 yards tall. Big smiley. You solve those word problems. Tomorrow in class we'll be working on other problems that use these same types of techniques. I want you to make sure that you take a chance to look at the You Try tonight, and I hope you have a wonderful evening.